Good morning, sir. My name is Yel Monica. I am from second year ACE A section. Today, I would like to explain about basic properties of the cross power density spectrum. The outline of this topic is Introduction to Spectral Analysis, Power Density Spectrum, Cross Power Density Spectrum, Properties of Cross Power Density Spectrum, Applications of Cross Power Density Spectrum, and Conclusions. Before going into the topic, let me explain the definition of the spectral analysis. Spectral analysis is a technique used to examine the frequency components of a signal. It involves transforming a signal from the time domain to the frequency domain, typically using mathematical methods like the Fourier transform. And the definition of the power density spectrum is a representation of the power of a signal is distributed across different frequency components. The power density spectrum is typically obtained by applying the Fourier transform to a time domain signal, which converts it into the frequency domain. For a stationary signal x of t, the power density spectrum can be defined mathematically as Sx of f limit t tends to infinity integral minus t by 2 plus t by 2 x of t e power minus 2 pi minus j 2 pi f of t into dt. The definition of the cross power density spectrum is it qualifies the relation between two signals in the frequency domain. It measures how the power of one signal is related to the power of another at different frequencies. For two signals, x of t and y of t, the cross power density spectrum is defined as Sxy of f integral minus infinity to plus infinity x of t into y of t e power minus 2 j 2 pi f of t into dt. Properties of the cross power density spectrum: linearity property, symmetry, non-negativity, interpretation of magnitude and phase, estimation, frequency resolution, causality under certain conditions. First property of the cross power density spectrum is linearity property. The linearity property of the cross power density spectrum indicates that the cross power density spectrum is a linear function of the input signal. Mathematical representation: if you have two signals x of t and y of t, and you introduce scalars a and b and another signal x dash of t, the cross power density spectrum satisfies is xy of ax of t plus bx dash of t, comma y of t, axy x of t comma y of t plus bxy x dash of t comma y of t. Second property of the cross power density spectrum is symmetry property. The symmetry property of the cross power density spectrum states that the cross power density spectrum exhibits conjugate symmetry, meaning that the spectrum is related between two signals in a reciprocal manner. Mathematical expression: for two signals x of t and y of t, the symmetry property is expressed as Sxy of f Syx into f. Non-negativity property: the non-negativity property of the cross power density spectrum states that the magnitude of the cross power density spectrum is always non-negative for real valued signals. This property is crucial for interpreting the power relationship between two signals. Mathematical expression: for the cross power density spectrum, Sxy of f xy of f, the magnitude is defined as Sxy of f greater than or equals to 0. Interpretation of magnitude and phase property of the cross power density spectrum. The magnitude of the cross power density spectrum, denoted as Sxy of f, qualifies the strength of the correlation between two signals x of t and y of t at a specific frequency. Phase: the phase of the cross power density spectrum, denoted as angle of Sxy of f, indicates the time relationship between the two signals at frequency. Estimation property of cross power density spectrum. The cross power density spectrum, denoted as Sxy of f, is a statistical estimation that describes the correlation between two signals in a frequency domain. It can be expressed as Sxy of f, expectation of x of f into y of f, where x of and y of f are the Fourier transforms of a signal x of t and y of t, and Fourier transform signals of x of t and y of t, and E denotes the expected value. Frequency resolution property of the cross power density spectrum. Frequency resolution refers to the ability to distinguish between two closely spaced frequencies in the spectrum. It indicates how well different frequencies components can be separated and analyzed in the cross power density spectrum. Causality property of the cross power density spectrum. In the context of signals, a system is said to be causal if the output at any time depends only on present and past inputs, not on future inputs. This means that for two signals x of t and y of t should not depend on x of t plus tau for any tau greater than 0. The mathematically it can be represented as Sxy of f of x of t into y of t. Applications of cross power density spectrum. Signal processing, system identification, communications, audio processing, control systems, vibration analysis. Conclusion of cross power density spectrum is a key analytical tool used in signal processing, time series analysis, and various engineering fields to explore the relationship between two signals in the frequency domain. It provides insight into how the power of one signal is distributed with respect to the frequency content of another signal, essentially quantifying the correlation between two signals at different frequencies. Thank you.